right, today's lesson is going to be about populations, samples, and hypotheses. A population is the collection of all data. Is the collection of all data, such as responses, measurements, or counts that you want information about. A population, though, unless it's small, it's usually impractical to obtain all the population data. So in most studies, information can be obtained from a sample, which is a subset of the population. Okay. It's important for a sample to be representative of a population so that the data can be used to draw a conclusion about the population. And when the sample is not representative of the population, the conclusions may not be valid. Drawing conclusions about populations is an important part of statistics. Remember, statistics is the science of collecting, organizing, and interpreting data. So let's look at these first two examples here. Identify the population and the sample. The owner of a dance studio asks 32 dancers what their favorite type of dance is, and 25 of them say hip hop. So what would the population be in this example? The population is all the dance studio dancers. So all the dancers in the dance studio. The sample is the 32 dancers surveyed. Okay. A counselor at Easton Middle School pulled 225 student class schedules and found that 46 students have science first period. So in this case, the population would be all students at the middle school. Okay, and the sample is the 225 class schedules that were pulled. A parameter and a statistic is a way of measuring the data. So a parameter is a numerical description of a population characteristic. And a statistic is also a numerical description, but it's describing the sample. Okay, so a statistic is a numerical description of a sample characteristic. So in these next two examples, let's decide if it's a parameter or a statistic. For all teenagers in a certain town working jobs last summer, the mean hourly wage was $6.95. Is the mean wage a parameter or a statistic? Why? Well, in this case, we're talking about all the teenagers in a town. So this measurement is going to be a parameter because it measures all teenagers' wages in the town. A survey of 912 men ages 50 to 60 in Central America found that the standard deviation of the length of their feet is about 4 centimeters. Is the standard deviation of the foot length a parameter or a statistic? Why? This one is a statistic because it's not talking about all the men, it's talking about a subset of the men, right? A sample, 912 of them. So this one is a statistic because it comes from a sample of 912 men in Central America. The last thing we're going to talk about is a hypothesis in statistics, okay? And in statistics, a hypothesis is a claim about a characteristic. Of a population. So for example, a claim would sound something like, a drug company claims that patients using its weight loss drug lose an average of 24 pounds in the first 3 months, okay? Or a medical researcher claims that the proportion of U.S. adults living with one or more chronic conditions is 45%, okay? And one of the ways that we can analyze a hypothesis is to perform a simulation. So one way to analyze hypotheses is to perform a simulation. Okay, and when the results of your simulation are highly unlikely to occur, then the hypothesis is probably false. Okay, there's a lot of claims out there, guys. Companies make all kinds of claims and throw around statistics all the time, and you hear it in the news. So it's important that you look at where this statistics is coming from. Is it coming from a sample? Is it coming from a population? Is it coming from a proper sample of the population? What kind of, experiments did they use to get this information? That's actually what we're going to talk about next time. So understanding this can give us a better understanding of the data that's being collected and whether it's true or false.